Just like in the previous weeks, I want to go ahead and go through an example of some code. So here I have some code I wrote. Here is my script file. And then I have my function down here that we're going to go over. But in this script file, I go ahead and create an array of random numbers between 0 and 9. A random length, we do 1 and 9. Random length, that's 1 to 10. So here's my rows, and then one column. But it's a random array. Then I go ahead and call the function SumArray that I use to sum the values in the array. So that means this A is passed into the function, which means I'm going to use the values here for my calculations, and then whatever my function calculates for the final sum is passed into S. And then here I print out my results. Here I print out the array values, summing them together, and here I print out my result. But let's go ahead and look through this function. So in this function, I'm going to sum all of the values in the array. So let's say my array looks like this: 5, 3, 6, 5, etc. Let me go ahead and move that down closer to our function so we can see it as we go through. But we can see I have a loop in here. So I have something I'm going to repeat over and over and over again. What am I repeating? These 3 lines of code. So I have current sum equals array 1. So in this instance, it's the first value in the array. So I'm going to say this is 5 for this array. It would obviously be different for a different set of values. Then I say for I equals 2 to the length of the array. So I'm saying I is 2 all the way to 1, 2, 3, 4, 5, 6, 7, 8. There are 8 values in my array. So I is 2, 3, 4, 5, 6, 7, 8. So I is going to start with a value of 2. Then it's going to have a value of 3, then it's going to have a value of 4, then 5, then 6, then 7, then 8. So I first equals 2. Next sum equals current sum, which is 5, plus array 2, which is 3. So that means next sum now equals 8. So here's where I print out some stuff. We'll see what that printing out looks like. Then I can see next sum equals 8, and then I say current sum equals next sum, so current sum equals 8. Okay, I've executed those 3 lines of code. I'm going to go back up to the top, and I'm going to go through my next value in I. I'm saying, did I run out of values yet? No, I'm going to go to 3. So next sum now equals current sum. Current sum is not 5 anymore. Current sum is 8. It's whatever I initialize it to down here. So now current sum plus array, let's see what else changes, array 3, because I is now 3, which is the 3rd value in my array. So that's 6. So 8 plus 6, which equals now 14. So I print something out, and then I say current sum equals next sum. So that means current sum now equals 14. Okay, I've executed my 3 lines of code. I'm going to go back up, and I'm going to say, did I run out of values? The answer is no. So now I is now 4. So here I execute next sum. Next sum equals current sum, which is now 14, plus array 4. Array 4 is this 5 here. So now I have 14 plus 5 is 19. Print out some stuff. Current sum now equals 19. Did I run out of values? No. So I now changes to 5. So that means current sum now is 19. Array 5 is 2. So now my sum is 21. So I print out some stuff. Current sum now gets a value of 21. Did I run out of values yet? No. I now goes to 6. Current sum is now 21. Array 6 is a value of 8. So 21 plus 8 is 29. So I print some stuff out, and now current sum stores 29. So did I run out of values yet? No. So now I goes to 7. Current sum is the 29 from previously. Array 7 is a 1. So now my new sum is 30, which means I print something out. My current sum is now 30. Go back up. Did I run out of values yet? No. So I go to 8. So current sum is now 30. Array 8 is a 3. So that means my sum is now 33, which means current sum down here is 33. Did I run out of values? Yes. I'm done with my 8. So now I'm going to go ahead and execute this here. I print out a new line, and final sum now equals whatever next sum was, which is 33. Okay, so final sum is initialized, send it back to my script, and I've executed my code. But we can see how this for loop iterates through all of these values in this array. I keep going through one number at a time. I can see how every time I'm executing my code, next sum changes, current sum changes. So I have to update my values as I go through following each iteration. And if we see how this is printed out, it looks like it's printed out over here. So just like we did manually following the lines of code, here what this line does here's my fprintf, print out a string of values, print out an integer with 2 digits, with 2 spaces, print out a plus sign, another integer, and then an equal sign, and then an integer with 2 spaces, and then a new line. So where do those values come from? This just inserts white space. So don't pay attention to that. It just nicely formats my things. But I'm printing out the current sum. So that's this one, current sum. Printing out the vex value in my array, and printing out what that adds to. So here I can see the first time I pass through my array, it's 5 plus 3, adding up these 2 values, which equals 8. Then the next time it's 8 plus 6, so now I'm adding up these values, that's 14. The third time it's 14 plus 5, which gives me this 19. And then I have 19 plus 2, and then I have 21 plus 8, and then 29 plus 1, and then finally 30 plus 3, which is 33. So essentially you can see we're adding one new value at a time every single time. And this will work for any size array because we stop when we get to the length of the array. That's why we have this piece here. This makes this code generic for any size vector. Let's be honest, it's really for any size vector. If we want to do it for a matrix, we would design it differently. But it works for any size vector because I stop whenever I run out of numbers, when I run out of locations to add. And here we can see it's all added up. This is what this prints out here. It all adds up to 33. I'm saying 5 plus 3 plus 6 plus 7. I'm just doing it 2 numbers essentially 1 number at a time. Adding up these ones first, and then these one, and then keep adding these one at a time. And the name for this is called a run-in sum. We would do this kind of strategy whenever we have a capital, oops, that's not a capital sigma. You'll see that happen in this class sometimes. This means a running sum, capital sigma, sum up a bunch of values one at a time.